Now we've talked about the special triangles before, and just as a quick review, there's two special triangles, right? You have one that kind of looks like this, where this is a 90-degree angle. This is 45 degrees, and this is also 45 degrees. And there's a certain ratio between all these sides, where we can say this is 1, and this is root 2. And based on this triangle, we can figure out the sine, cos, and tan of 45 degrees. Then you have another triangle that's a little bit more useful because it's got two different angles instead of both being 45. And it looks something like this, depending on how you draw it, where this here is 30 degrees and this up here is 60 degrees, right? And this length here is 1. This length on the bottom here you could say is root 3 and the hypotenuse is 2. And again, those could switch depending on how you write this. You could put the 60 here and the 30 here and those sides would switch. But basically this is used to help find the sine, cos, or tan of 60 or 30 degrees, right? So between these two triangles, you can find the sine, cos, or tan of three different angles, right? 45, 30, and 60. Now, a new concept that we can use, and this is something I actually prefer to the special triangles, is what we call the unit circle, okay? And so just as an introduction to the unit circle, imagine you have a plane just like this, and each quadrant is going to have the same thing, but I'm just going to show you up here first. If you have an arm going like this, and we'll assume the radius is 1, and this is 45 degrees, right? It's basically this triangle here. If you draw a line straight down, it's that same triangle, right? If we scale it so that the radius is equal to 1, or the hypotenuse is equal to 1, same thing, instead of root 2, then we're just scaling down the triangle, right? So if that's 1, then instead of this being 1, it's 1 over root 2, and this length here would be 1 over root 2, right? We just scaled down the triangle. If that's 1 over root 2 and this is 1 over root 2, you could find where the coordinates of this point are, right? Because it's 1 over root 2 to the right and up 1 over root 2. And you could say, oh, that's 1 over root 2 and 1 over root 2, just like that, right? That's where that point is. And you could do the same thing for the 30-degree triangle, right? You come out like this. You could do the same thing for the 60-degree triangle. You go up like that. And you could find all these coordinates. And if you draw this to scale properly, right, you're going to get a nice circle that's going all the way around, and it goes around the unit circle, and it connects. Now, what this allows you to do is you can look at the circle and find any angle that you're discussing, and you can find the x and y coordinates of the point on the end of the hypotenuse. And those, as we can see here, this represents your height, this represents this adjacent side here, and those are essentially your sine and cos values, right? Because if I say, what's cos of 45, right, what's cos of 45 degrees, you can look at this triangle here and say, oh, it's adjacent over hypotenuse, so it's 1 over root 2 divided by 1, so just 1 over root 2. If you say, what's the sine of 45 degrees, you look at this side over here, and it's, 1 over root 2 divided by, 1. So because the hypotenuse is 1, you don't really have to divide by it, right? And so really you can just look at these coordinates here at the end of the point, right? Or at the end of that line. So if you see 1 over root 2 here as your x value, that's your cos. And if you look at this value here, your y value, that's your sine of whatever that angle is. So let me show you what this really looks like, the unit circle. Okay, here we go. So if it looks a little bit intimidating, that's okay, right? But it works exactly like I was saying. If you have the 30-degree triangle, right? So imagine that this arm here is the hypotenuse of the 30-degree triangle, right? Just like that. This here is 30 degrees. If you want to find sine of 30 degrees, sine is opposite over hypotenuse. Well, the radius here is always 1, right? The radius of the circle is 1. So all you got to do is look at the opposite, right? Well, the opposite is the height, which is this value here. So sine of 30 degrees is a half. If you want to know cos of 30, it's this number here, root 3 over 2. If you want to know sine of 11 pi over 3, you find 11 pi over 3 or 330 degrees, you say you want the sine, so it's negative a half, right? Which makes sense because it's going down the same amount that this one's going up, right? So they have the same sine value, one's just negative. And actually what's really cool about this circle here is that you can come up with this pretty easily, right? Like this is one of the special triangles. This is the same special triangle here, just flipped on the other side, right? Because it's 60 degrees instead of 30. And then you have the 45-degree one here, right? And so all of these 3 points, or these 3 lines, 1, 2, 3, those are all just based on the special triangles. So if you know the special triangles, you can come up with those. Now when we're talking about, this arm here, this one here, this one, and this one, we should know what those are, right? Like if I say 90 degrees, what's sine of that? Well, we know sine of that is 1 because it's going straight up, right? It has a height of 1. And if I say what's cos of that, you should know it's 0 because it's not going to the left or right. There is no adjacent side, right? So it's 0. And you can see that trend continue at all of these points. Here is 0, 1, negative 1, 0, 0, negative 1, 1, 0. Because again, the first value represents your x direction and the second value represents your y direction or your sine, right? So if you know those four and you know your special triangles, you can make this whole thing up, right? You can come up with this because if you look at the coordinates, like this and this are the same. It's just this has a negative x value because it's going to the left. This is the same as this, except it has a negative y value because it's going down instead of up. This here and this here are the exact same, except this one down here, they're both negative because it's going down and to the left, whereas this one's going up and to the right. So all those coordinates are the same. It's just a matter of direction, right? The negative or positive just indicates what direction you're moving in. And so this is really, really useful because if you have this on hand and you need to know what sine or cos of a certain angle is, whether it's in radians or degrees, you can reference this, find your angle. Like let's say you want 225 degrees, you come down here. You want to know cos of that, you just look at the x value, negative root 2 over 2. And that's it. You just get your answer from right there. So this is really, really helpful because in the past, if you want to figure out the sine or cos or tan of a number, you have to use the special triangle. But then once you find your answer, you have to think about direction, and you have to draw this thing out and figure out, okay, my angle's down here, right, going like that. So if I want cos of that, it's like, okay, it's still positive. So, okay, I get the positive answer. Or if you want sine, it's going down. So it's got to be negative. You don't have to worry about that, right? You don't have to worry about whether it's positive or negative. You can just look on the circle and get your answer. And the signs are already there. So this is a nice tool to have, especially on tests, because you can get your answers really quickly just by looking at it. And a lot of teachers will give you this on a test or ask you to bring it in yourself. One other thing I'll say, if you want to find tan of one of these angles, like if I want, tan of 3 pi over 4, what do we do? Well, to take the tan of something, it's just the sine divided by the cos. So you just divide these two numbers. So root 2 over 2 divided by negative root 2 over 2. They're the same numbers, so they're going to be 1. This one's negative, so you get negative 1. And again, that references the slope of this line. That's what tan is, right? So the slope of this line here is negative 1. And that makes sense because it's a 45-degree angle, right? It says 135, but it's the same as the 45. It's just going down, right? Like this related acute angle here would be 45 degrees. So of course the slope of that is 1 or negative 1, right? Hopefully this makes sense, and we'll continue to use this circle as we tackle more problems in the future.